And welcome everybody to the Daily Space Weather Show. We're looking at the past 24 hours of action from El Sol, Helios, the local yellow dwarf. And you might see some activity going on, especially in the southeastern limb. That would be your lower left, because that is the location of our T-mass, the most interesting sunspot, which is currently in view on the Earth-facing portion of the disk, as well as the most active region. So the largest flare of the past 24 hours actually came from an active region that is not yet visible. So we've got another likely sunspot to rise there in the southeast. The one just below the Earth scale is the most interesting and most magnetically complex sunspot, and we'll talk a little bit more about that a little bit later in the video. These are 24-hour videos at 30 frames per second. That's SDO 171 angstroms, one of the many species of ionized iron covered by the Solar Dynamics Observatory. By the way, don't forget to press the like button. If you're new to the channel, don't forget to press subscribe. Otherwise, how will you receive the world's most comprehensive daily space weather content and most detailed solar imagery in your YouTube subscription feed? I don't know how you will. Certainly not without subscribing to the channel, because it's without any equal. Now, you may appreciate the wardrobe today. If you want to pick up some space wear of your own, hit up our Amazon shop. It's amazon.com/shop/smashomash. Links below the video to that. You can find this very hat and indeed this very shirt in our spacewear collection. The quote of the day today is, and I can relate to this one because I began skateboarding in 1983. The only time you fail is when you fall down and stay down. A great quote there by Stephen Richards. Perhaps he has done some sidewalk surfing of his own, perhaps, right? So yeah, it's if you've fallen down tens of thousands of times, what it's probably done to you is made you really good at getting back up. Anyway, let's get through some space weather stats here. The space weather stats start out with the 10.7 centimeter radio flux, a proportional data set to sunspot number. In other words, when you see a high sunspot number, you see a high radio flux, and vice versa. The current situation for radio flux is 164 solar flux units. 164 is the current number, and that black line over there at solon.info is the past year of radio flux. You can expect to see higher highs and higher lows continuing for another 3 to 5 months. Now, just a brief comment on that. Many forecasters have now basically downgraded the peak of sunspot number by extending when solar maximum is expected. So at least NASA and NOAA, I believe, are now expecting solar maximum to arrive about 2 months later in December, which is essentially a downgrade for sunspot number. Why is that? It's because longer solar cycles are weaker cycles, and the strongest cycles are also the shortest cycles. So yeah, so that's basically a downgrade in terms of how high the sunspot number will get. The fact that it will be 2 months longer, although it's, you'll still have activity similar to what we have now for at least 6 to 10 months. So if you like activity at the levels that we have it now, that's good news for you. If you're expecting a really high sunspot number at solar maximum, it's bad news for you, if that makes sense. Hopefully that read. Anyway, 166 is the current radio flux number. And we are expecting a coronal mass ejection impact sometime after midday tomorrow on Sunday, July 7th. So nobody else seems to be forecasting that one, but we saw a coronal mass ejection on Independence Day, so we independently forecasted what we saw. Now, we don't really compare notes with anybody. We just call them like we see them on the channel. So CME impact expected tomorrow, sometime after midday, July 7th. Could see as high as KP 7.66, fingers crossed for that. Hopefully tomorrow night, aurora will be visible at mid-latitudes. So again, NOAA's not forecasting that, and neither is ESA. Now, we would take a look at NASA's forecast, but unfortunately the Integrated Space Weather Analysis Center is down, so we can't get any data from that, including things like flare probability monitoring, but we'll show you the breakdown of the magnetic fields and so forth, because ultimately that's what really determines that anyway. Now, as far as Earth's magnetic moment from space, we have very calm geomagnetic conditions at the moment, and it's because the solar wind is not just diffuse, it's very slow, around 300 kilometers per second, which is about as slow as it ever gets. That's the kind of solar wind that you see around solar minimum. So yeah, really slow solar wind. If we do see any kind of signals, they will be significant with a solar wind that slow. And we are seeing some differences at the ACE versus the Discover because of a floundering, fluttering, filamentary facade showing up. We'll get to that in a minute. First, we'll show Earth's magnetic moment from the ground. So that's Earth's magnetic moment from space for the past 4 hours. Here's the ground magnetic perturbations map. Earth's magnetic moment from the ground. This depicts changes to the Earth's B field. So the B field is the field that goes through the magnet. We'll show you the sun's B field here momentarily. That's the Earth's B field, or changes in it, geospace delta B. When you see delta in science, that means change to. So things are quite calm. KP is at 0.67. 0.67 is the KP index, an average of global geomagnetism. Now, if you look at ACE, ACE just has a very diffuse and very slow solar wind there at about 2 protons per cubic centimeter density. Solar wind velocity 335 kilometers per second. And here's this fluttering solar wind. So that's what you would see if there'd be like some filamentary features showing up. Just some minor filamentary activity there causing these variations in the solar wind density and the plasma speed. So that's a filamentary impact, or a coronal mass ejection impact, whatever you want to call it. But current conditions, we've seen a little uptick there actually. So current conditions are about 7.7 protons per cubic centimeter, but look at how slow the solar wind speed is. Barely making it over 300 kilometers per second at 306. GOES magnetometers are smooth, and the GOES magnetometers are measuring the magnetic fields of the Earth's outer Van Allen belts. So keep in mind, folks, you can't measure the sun's solar wind magnetic field from inside the magnetosphere. The GOES magnetometers are inside Earth's magnetosphere. They're measuring Earth's magnetic fields, the outer limits of it, the outer portion of the outer Van Allen belts. That's at about 23,500 miles of altitude, the GOES 16 and GOES 18. Next magnetic moment from space, moving on to the heliosphere magnetism. So now this is looking at the sun's magnetic field, the magnetic field that is projected outward by solar plasma. The solar plasma sort of carries its own magnetic field with it, the same way coronal holes do. And what you've got here is Earth has just recently snapped into a South Pole-oriented magnetic sector. There you have that. You can expect to be in a South Pole sector for the next 24 to 36 hours, maybe as much as 2 days. I suspect by tomorrow's Daily Space Weather video, Earth will still be in that red-colored South Pole magnetic sector. So here's the sun's B field I talked about later. That's depicted in blue. The polar fields are in green and red for north and south respectively. And then you've got the photosphere magnetism as well. That's the layer below the corona and below the chromosphere where sunspots occur. That's the grayscale imagery there, the photosphere magnetism. And we'll bring up the last image here once that plays through one more time. There you go. That's the current state of affairs, and moving on to coronal holes. So you can expect there to be South Pole-oriented coronal holes facing the Earth and North Pole ones rotating in here shortly, and that is exactly what you see. Welcome to the South Pole magnetic sector. It's not going to last more than 48 hours, most likely. As you can see, some green over there on your screen left, that would be North Pole-oriented magnetic sectors rotating in. Next, coronal holes from SDO's perspective before we move on to sunspots. That's what's going on with coronal holes. And that one that's right in the Earth-facing zone there, that one can be expected to produce some increases in the solar wind density in about 2.5 days, followed by a decrease in density and an increase in solar wind speed. That's the way coronal hole high-speed streams work. They start out with a density increase, and then when the density drops, you can expect to see a velocity increase. So there is the little closer zoomed in view there for you. 211 angstroms is one of the species of ionized iron there covered by Solar Dynamics Observatory. And more coronal holes rotating in. You can expect to continue to see lots of coronal holes in the trans-equatorial zones for the next 6 to 8 months. So that's the scenario for that, and let's move on to sunspots. Sunspot number has continued to decline here. Current sunspot number is at about 124. 124 is a sunspot number. And let's take a look at sunspots from SDO. There you have it. That's another 24-hour video for you. And the most interesting sunspot, in my opinion, is the one in the east. So you can see that 4 main large umbrae there. It is pretty magnetically complex. If you see our community posts, you would probably already know about this. But if you don't see our community posts, we aren't surprised. If you want to check them out, you'll see all kinds of references in there. youtube.com/smashomash/community. Maybe save that one in your favorites, because you'll see all kinds of recommendations in our community posts. So here's our magnetogram. Now, we still do have a significant possibility of large flares at that western limb. But in my opinion, the most likely place for a large flare is in the east, and that is indeed where we've been seeing the largest flares. Let's move on to energetic particles and flares. Since I brought it up, let's continue on that line. So, no solar energetic particle events, or SEPs. That's what we're looking at with the ghost proton flux. And when those relativistic particles show up, they orbit Earth's magnetic field lines, and they emit radiation as they slowly lose energy. That's what you call a proton event. We ain't got none. Things are smooth. And you can expect normal radiation doses on your polar flights. So, largest flare of the past 24 was around 9:40 Universal Time this morning. And actually, here's a brief look at where it came from. That's not what I wanted. There we go. So yeah, there's where it came from. It came from behind the limb. So expect to see a sunspot rising soon down there in the southeast. That would be south of sunspot 3738, which is the most interesting sunspot currently visible from Earth. All right, so there's the X-ray flux over the past 3 days. And here is the past 24 hours. 94 angstroms from Solar Dynamics Observatory. There was some flaring there in the southwest, which would be your lower right as well. But no major flares, only C-class intensifications for the past 24 hours. And we're going to show that new exciting region in the southeast. So let's cut to a close-up of that, shall we? That's a rhetorical question. I wasn't asking. So there is that southeastern limb. That is T-Mass, the most active sunspot. One not yet even in view. But again, it's quite promising. The sunspot that's to its north, the one closer to the Earth scale there, that is sunspot 3738. It's already got a name. And here it is in 131 angstroms. Just some splentacular imagery there. Not bad. Not bad. All right, next we're going to show a solar system forecast. As we do, there is the current state of affairs in the solar system. And let's advance this 1 week. Happy new moon, by the way. Shout out to all of our reverse werewolves, people who sleep well at night and don't cannibalize humans, worship the devil, and have, active, normal, productive lives. You know, normal people, reverse werewolves. Yeah, congratulations. New moon, my favorite phase. There's where things will be in a week on the 13th of July, the 13th. And here's a brief look at a star chart over our head right now. We've got the sun, the moon, Venus, Mercury. That's what's going on. As the sun is in Gemini, which means something to someone as well. Next, we've got an open cluster. It's called NGC something or other from the new general catalog. And an open cluster is a series of stars that have similar mass and coloration. So that is one way stars are classified. And what makes it an open cluster is the fact that they are not orbiting a common point of gravity. They're just similar stars. So their magnitudes, their colors, and their masses are similar. But unlike a globular cluster, the open cluster is not. Their relative motions are sort of not all orbiting one center of common mass. That's the astronomy photo of the day, apod.nasa.gov. Next, CMEs, and we've had a number of quite spectacular coronal mass ejections. So that's today's images from George Mason University. And you might think those are earthly directed. Well, we've looked into it. And sadly for all you aurora chasers, well, I don't think those are earthly directed. I don't think any of them are. So sorry to bring bad news. But yeah, that's the current state of affairs. The past 24 hours there featuring the LASCO C3 in blue, the C2 in red, and synchronized is the SDO ionized helium imagery there. That's 304 angstroms. So pretty sweet light show there, but not likely to be producing any geomagnetic storms. So we'll zoom in one step here before we move on to filaments. Now, if those were earthly directed CMEs, you would see some wild plasma motions there, as we've added the 193 angstrom 60-minute running difference to the SDO imagery in the center of your frame. But we ain't seeing that. We ain't seeing that. These are limb coronal mass ejections. They're pretty sure they're not earthly directed. About 99% sure that they're not earthly directed. And let's move on to filaments. So we've got some great views of filaments. There they are from Cerro Tololo, Chile. And we do have one named filament. There is at least one other one that's worthy of a name there in the southeast. So that's the filament scenario. And we have some prominences here, quite a few of them. So in addition to some crown prominences, many prominences there in the east, indicating the likelihood of more active regions and or sunspots to rise soon in that eastern, especially the southeastern limb. So fingers crossed for that. And before we move on to bonus features, we're going to save filaments for the end of the video. Let's blast through bonus features. These are the past about 2.5 hours from the GOES 16 SUVI. And lots of filaments there. Lots of filaments, and many of them are prominences. So they are the same features. You may see a dark absorption feature just west of center disk, south of the equator there. That one has been named. That's the Sarahusial filament. If you don't know who it is, well, you should follow us on Twitter, x.com/smashomash. Here come bonus features. Charging hazards, there are none. Electron flux remains kind of low. There's the forecast model from NOAA represented by the green boxes. Next, the layer where it's measured, the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with atmospheric layers and their temperatures, electromagnetic radiation penetration into atmospheric layers, and chemical concentrations. The F layer is at 300 kilometers of altitude or so. There it is, the ionoson, courtesy of Australian Government Bureau of Meteorology. Not seeing any major anomalies in that, which is no surprise, as we've gone an extended period without any significant space weather. So very average there. That's the anomaly in megahertz from a 30-day median. Quite nominal. Of course, except for one factor, the South Atlantic anomaly has moved to the South American coast around the 45-degree west longitude line. But besides that, nothing really going on to affect the ionosphere in the realm of space weather. Does it tell us something about the pole shift? Probably. Is it a harbinger of doomsday? Probably not. Are Earth's orbital mechanics affected by things like the magnetic field? Absolutely not. And here's the ionosphere, the global ionosphere nowcast. Maximum usable radio frequency over here on the right. On the far side, total electron content. And before we cut back to filaments for a brief moment, we'll show the latest high-res images. All right, so first this sunspot before it sets, it's beta class, not even beta gamma class, so it's kind of unlikely to produce large flares. This sunspot over here, that's 3738, it's beta gamma delta class, which is the classiest class to produce high-class flares. Of course, again, there is another active region there, or two rising. So we'll be keeping an eye on that. And when I say ion, well, pardon the pun. It was intentional. We're seeing a further decline in sunspot number here, so expect a decline in sunspot number moving into tomorrow. Anyway, once again, filaments. Here we've got the 193 60-minute running difference imagery and the 304 angstroms from SDO. We'll zoom in. And right down here, this is the Sarah-Husial filament. There is another one over here that's quite dense that you could name. Just follow the hashtag name that filament. Over on X, just tell us which filament. Follow the hashtag, put the hashtag name that filament in the post. Tell us which filament, who you want it named after, and tag us at Smashomash. So here's a close-up to close out the video of the Sarah-Husial filament. We've been naming them after living people, kind of in the way that storms are named and so forth. It seems kind of fun. So you're welcome to participate, or not, in which case I'll just name them after whoever I want. Last but not least, we've subtracted the 193 angstroms 60-minute running difference and added 171 angstroms. So there you go. That is where we'll close things out. Thanks for tuning in to the Daily Space Weather Show. Once again, congratulations on realizing the channel exists, and may that solar wind be at your back.